Hello and welcome to the video channel of the CRC 768, Managing Cycles and Innovation Processes. During the next minutes, I will introduce the topic of engineering change management and will give you a brief overview of the activities of the engineering change management process. Let's talk about the importance of engineering change management and the definition of engineering changes first. Why is it important to have an engineering change management system? If you look at a study conducted by Fricke, engineering changes tie up to 30% of the development capacity. Hence, handling engineering changes efficiently has a huge impact on the overall development performance. The cause of these changes, however, can be widespread, from altered requirements to very specific component failures. The scope of engineering change management becomes more clear when we look at the definition of an engineering change itself. An engineering change usually describes a modification in fits, functions, materials, the dimensions of a product and constituent components after the design is released. This means if any development artifacts gets released, a change to it should trigger an engineering change process, since there's a high chance the change can propagate. This slide shows the structure of the engineering change management with its constituents. We can see several activities and elements of change management like anticipation and planning or effects analysis. In addition, engineering change management includes the process to conduct the changes. However, we can split the activities of engineering change management in three major phases: a phase before the appearance of an engineering change, a phase of the actual handling of an engineering change, and a phase for utilizing past change data. The first phase describes all activities before the actual appearance of a change request. This includes, for example, the anticipation and planning of the product architecture, a proactive identification of future technology trends, and a continuous validation of requirements to prevent light changes in the development phase. Furthermore, identifying cycles in the development process beforehand can reduce the actual amount of engineering changes. The first phase, therefore, represents the proactive change management. The second phase addresses the actual handling of engineering change. Therefore, a process guiding through the steps necessary to successfully implement the engineering changes is defined. This includes an effect analysis to reveal possible change propagation. We call the second phase the reactive change management. The third phase, with the engineering change management, groups the activities to the analysis beyond change data. By the retrospective assessment, an evaluation of the change management system and its efficiency is possible. We call this phase the retrospective change management. In this video, we want to focus on the reactive change management and explain the developed reference process in detail. Developed ECRP, or engineering change reference process, consists of 5 major steps: the identification, the preparation, the decision, the operation, and the controlling. Each of these steps includes several activities which describes the procedure in more detail and contribute to the overall goal of each step. The identification step is the first activity in the identification of the target deviation. The second step is the assessment of the situation regarding the necessity to change and relevant boundary conditions. Here, the further procedure is defined roughly. Within the following preparation step, more information is gathered, with cause analysis in order to identify the technical cause behind the target deviation. Several causes of action are elaborated. For each course of action, the dimensions and extents of resulting effects are estimated. The results of the preparation phase is an engineering change request, or so-called ECR, that describes the target deviation, the underlying technical cause, potential solutions, and the relevant effects. Based on the ECR, the next step, you have to decide whether there will be a change at all, and if so, what solution should be implemented. The result of the decision phase is an engineering change order, or so-called ECO. During the operation step, all actions described in the ECO are executed. The effects of the change have to be recorded during the implementation in order to derive lessons learned in the closing controlling phase. Here, estimated change effects are compared to actual effects. The controlling step includes a matching of these results. This means the actual result of the change process is compared to the predicted result. Hence, the quality of predictions for change effects can be enhanced. Thank you for watching the brief introduction into the engineering change management, and if you liked the video, please subscribe to our channel.